What is up, Algebra 1? This is lesson 9.4. Our objective is, how do you solve quadratics using square roots? As you recall from whenever we were graphing and solving lesson 9.3, we can end up with one solution if it's like this red one or this blue one, where just the vertex is on the x-axis. We can also have it where the vertex is below or above the x-axis and it crosses twice, meaning we'd have two solutions, like these two red ones or these two blue ones. And also, if it doesn't cross at all, like this red one or this blue one doesn't cross the x-axis, that means we have no real solutions. We'll learn how to find solutions for this later, but for now we're just going to say no real solutions. So just remember that you could have one, you could have two, or you could have no real solutions. So before we jump into solving these, we need to just kind of do a little bit of recap. Remember, whenever something is squared, it just means something times itself. 2 times. 1, 2. So if we took 2 and squared it, that means 2 times 2, which is 4. Well, something similar would happen if we took negative 2 and squared it. It would be negative 2 times negative 2, which again gives us 4. So if I were to ask you what values of x make this equation true, you'd have to think, well, if I put 2 in here, it would come out to be 4. But it would also be true if I put in negative 2 into here. It'd also come out to be true. So whenever we solve something like this, and we have an x something squared equals a number, we can take the square root of both sides, and we would end up with x on the left-hand side, because those are opposite operations, squaring and square rooting. On the right-hand side, the square root of 4 is 2, but then because of this right over here, we need to add on something else. We need to say plus or minus 2. It could be the positive version, or it could be the negative version. So let's go ahead and just jump in and solve some of these. And the first thing we want to do when we're trying to solve these is we want to isolate the thing that's being squared. In this case, it's just an x squared. So to do that, this is multiplying by 25. The opposite of multiplying is to divide. So I'm going to divide by 25. So I end up, those reduced to 1, I end up with x squared is equal to 16 over 25. Well, now that I have this x squared by itself, I can do the opposite of squaring it, which means taking the square root. Take the square root of this side, take the square root of this side, which means x is equal to, and I'm going to add in that plus or minus, both the positive and the negative version will make it true, the square root of 16 over the square root of 25. Now remember that property, you can take the square root of the top divided by the square root of the bottom. Well, those are both numbers that I know, because the square root of 16 is just 4, and the square root of 25 is 5. So x is equal to two different numbers, either the positive 4 over 5 or the negative 4 over 5. So this one has two solutions. Well, let's try another one. Again, we want to isolate this one with the squared in it, or what's being squared. So I'm going to go ahead and subtract that 12. So I'm going to have 5w squared is equal to, those two went to 0. Those have the same sign, so it's just like adding them, and I keep the same sign, so it's going to be minus 20, because 8 plus 12 is 20. Continue isolating here, divide by 5, and I end up with w squared is equal to negative 4. So now that I've isolated my w squared, I do the opposite of squaring, which is square rooting. And the left-hand side becomes w, and the right-hand side is because we cannot take the square root of a negative number. In fact, if you plug it in your calculator, it'll give you non-real solution or something, or give you some kind of error saying it cannot find the square root of a negative number. And again, we'll talk about being able to do that later, but for now, we're going to say no real solutions. Alright, let's do another one here. Again, we see this thing that's being squared, so we want to get that by itself. So I'm going to subtract 11 from both sides and end up with 2x squared is equal to, well, 11 minus 11 is 0, and it's 0 over there as well, so it's just going to have to be 0. Almost there, but I need to, it's multiplying by 2, so the opposite is going to be divide by 2. So I end up with x squared is equal to, well, if I take nothing and divide it by 2 people, they each get nothing. So then, I just need to take the square root of x squared, and I would say x is equal to, and normally I would say plus or minus, and the square root of 0 is 0. However, 0 is that one special case that there isn't a positive or negative version of 0, right? So I don't need that plus or minus. I'll just say x is equal to 0, and that would be just one solution. Now that seems all easy, but they want you to be able to do a little bit more. So notice here, we still have something being squared, but it's not just one letter. It's a letter minus 3, right? This q minus 3 is being squared. So what I want to do is I want to isolate this thing that's being squared. So first thing I'm going to do, since this is multiplying by 4, the opposite of multiplying is dividing. So I'm going to divide both sides by 4. Those 4's reduce to 1, and I end up with that q minus 3 squared is equal to, well, 28 divided by 4 is simply 7. Now we've isolated this thing that's being squared, so the opposite of squaring is to square root. So take the square root and the square root. So on the left-hand side, I end up with q minus 3 is equal to the plus or minus, well, the square root of 7 is just that, the square root of 7. It doesn't have a perfect square like, say, 9 or 4 or 16, so we're just going to leave it like this. And now in this case, I'm going to split this up into two different equations, because I actually have two different equations. I have this q minus 3 is equal to the square root of 7, and I also have this q minus 3 is equal to the negative square root of 7. So now to solve each one of these, I would need to add 3 to both sides. So I'd end up with q is equal to the square root of 7 plus 3, or if you want to say 3 plus the square root of 7, those mean the same thing. And so if I wanted an exact answer, that would be it. Or if we wanted to approximate, I'll have to plug that in my calculator. I'll just plug in 3 plus the square root of 7, and I will get approximately 5.645. So this is one of my answers. Now let's look at this other one. Again, I'll need to add 3 to both sides. So that means I'm going to end up with q is equal to 3 minus the square root of 7. So again, that would be an exact answer like this. Or I can approximate it and plug that in my calculator. And I get 0.354. Before you rush off, your homework is 4 through 48, but notice there's a star 4. I don't think we've had one like this. That means you're going to go by 4s. So you start with number 4, and then you're going to go to number 8. Then you're going to go to number 12. Then you're going to go to number 16, etc., etc. So don't do all the even ones, just do the ones that are multiples of 4. I also will note that you only have 12 homework problems. I know, I'm sorry you want more homework, but today it's just 12. Good luck, guys.